Okay, Rolf, you're from Greenliant,
Yes.
a company which is quite unknown to me
Okay.
and to our readers maybe as well.
Yeah.
Maybe you can tell us a little bit what Greenliant is doing.
Yeah, Greenliant is we design and manufacture embedded mass storage devices. So these are managed NAND products which look to the system like a hard disk drive. So we have three main sort of product families, which is a parallel ATA interface product, which is a PATA. We have a serial ATA product range, and also new for the show here, we're announcing an embedded MMC technology. MMC being a multimedia card protocol, which is very like SD, but it's designed to be embedded and surface mounted on a PC.
Okay, and, which capacities have
We go all the way up to 64 gigabytes in a single package. So the package style essentially is a BGA mounted device, but we have up to 64 gigabytes in that package. So depending on the technology, the capacities are slightly different. So we have parallel ATA. The eMMC product is slightly smaller form factor, but we go up to 32 gigabytes, and the SATA one again is up to 64 gigabytes.
And what about the price or the cost? Because the memory business in general is under very
there's a lot of
pressure.
There's a lot of price pressure, but obviously there's still a requirement for reliable mass storage media. So one of the things we've done that we've announced at the show this week is produce a multi-level cell-based product that has the industrial temperature range capability. So we do full -40 to +85, but using a lower cost multi-level cell technology. And that has significant cost benefits over single level cell, which is a reliable technology, but it is also expensive.
Can you explain us how did you could get these high temperature range?
A lot of hard work is the main thing, but we within the NANDrive we have our controller and NAND die, and we buy a wafer which we screen to the industrial temperature range, and that with a combination of our controller technology allows us to fully test and qualify over the industrial temperature range. So the NAND drives that we ship are actually final tested at -40 +85. We don't just do a room temp test, we fully test it at temperature. So quite a challenge, but a very reliable, very good solution.
Can you tell us a little bit the industries or applications your products are going in?
We don't go after the consumer space, so we are very much targeting industrial embedded, the guys that you see at the Embedded World Show. And the reason for that is their requirements are more like data integrity, power fail integrity, reliability and long-term availability. The NANDrive package product, we maintain the package and pinout throughout the generations of the device and future generations. So one PCB design, you can use 512 meg all the way up to 64 gig, and for the next foreseeable future in terms of product generation. So in fact, one of the things we've got at the show is on our booth is a power fail recovery demonstration. So we actually have a NANDrive running in a very file intensive application and just cutting the power and showing that it restarts, you have a working drive, file integrity is good. So that's really what the embedded space needs, that reliability.
Okay. 64 gig is a quite big capacity.
Yes.
Is it possible to increase it by parallelizing devices?
It is. I mean, because it's a disk drive. So, for example, the PATA device, you could have two 64 drives, one as a master, the other as a slave. For the SATA devices, you can have as many SATA as you have port availability. So the capability to go beyond that is there. Obviously, we have a limited space inside the package to put more die. So, but as NAND technology changes, the geometries shrink and the capacities get higher, we can move to higher densities. So it's really driven by those factors.
Okay, thank you very much.
Good, all right, interesting talking to you. Thank you.